Hello everyone, today's another video about the Flux diffusion model. We're going to train LoRA models that can create similar styles of images. For this one, we're not going to use ComfyUI, we're using the AI Toolkit GitHub project. The benefit of creating a similar style is that, as we mentioned, we create AI video scenes using Flux, and we can bring images to the AI video generator in other production steps. So let's see how we install the AI Toolkit. First, we have the installation script. With Linux and Windows versions available, there's a requirements description for training a LoRA. Locally, the minimum requirement is 24GB VRAM for training LoRA models in Flux 1 Dev. We need a Hugging Face access token to download the Flux 1 Dev models and also to create environment files for the project. For training, we need to configure the settings files, and we use Python run.py to run the configurations for the specific LoRA model training. Let's see how we can do that on a local machine. First, we're going to open up the command prompt window, as I've done the previous steps already. We need to git clone the AI Toolkit project, download it, and access the AI Toolkit folder. We need to use git again to install the necessary components for the project. Here, I've used Conda to create a virtual environment, and I'm using Python 3.11. Once we finish, as you can see, with Python 3.11 specifically created, we can activate the Conda virtual environment by typing conda activate AI toolkit. Then inside this virtual environment, we can start installing Torch and Torch Vision. I'm using the CUDA 12.1 version. And once you finish, you'll see a list of components installed for PyTorch and Torch Vision. Lastly, we're going to run the requirements.txt for any necessary components for this project, and we're going to install these together. It shouldn't be any problem. Once you see all the collections, downloads, and installations of each component in the requirements.txt finish, you'll see basically a similar successful download and installation message appear in the command prompt window. In the command prompt window, we'll see the setup, Python script, etc. all running, and you'll see the list of component installations, collect packages, and there's a list of these components installed. Wait for a moment, and it will appear again for the next command prompt line, allowing you to type stuff. So right here, we come back to the installation message. As you can see, everything has been successfully built, and we're moving on to the next step, which is preparing the LoRA training dataset. For the dataset, I am using images from my AI video short stories, one of the characters from that. Basically, this character likes to wear blue-colored dresses and clothing. I'm using 30 images from that AI short story video character that I created before and put those files into a folder called Images. I resize them before bringing them to training, but before that we need to do captioning. In ComfyUI, there's an easy way to do captioning, which is using the recently launched model called Florence 2. With Florence 2, we're able to look up a list of images from a directory. From here, we got the image list from directory custom nodes. Now I am gonna fast forward this as I recorded my progress for create this captioning workflow. I built this to save text for each image's caption, and I've also tried to save the image by extend custom nodes. There's another option, as we've mentioned, the IFAI tools that's going to connect to the locally hosted Ollama. In Ollama, I'm installing a language model called Lava, which is a vision-enabled model similar to Florence 2 that's able for image-to-text. Therefore, we can use this language model for captioning. I added a node called ifDisplayText. We can see the text caption in ComfyUI while it's generated. This workflow simply generates the caption text and stores all in a txt file for each of the images in the output folder. And I'm using the date and time to simplify the subfolder name. Here's the Olama using lava generated result. I've used a folder called the date and underscore lava. For the dataset, lastly, you put all files together with resized image files in a folder. I've resized all the images to 1024 by 1024 just for the same dimensions for all of the images. Then come to the configuration folders. In the config subfolder, there are examples for training your LoRA. Use this train LoRA Flux 24GB.yaml file. You can use any text editor. In this example, I'm using Visual Studio to edit the code in this config file. In the name section here, I use my character name with LoRA v1, and for the device, if you have one GPU or display card, then just use CUDA 0. That is by default the GPU that's going to be running. I enable the trigger word, which is woman for this LoRA model. So once we type any text prompt that includes woman and connect this LoRA model, it will enable this LoRA style for my images. Right here, we have the folder path for our image and the txt files for each image. So I put that into the same folder and just copy and paste it into the folder path variables here. For Windows, remember to use double backslashes for each folder name in between. Then you're good to go. Confirm the captions extension is txt. Of course, we have to check the training steps here. By default, this configuration is 2000 steps, so I'll leave everything in the training configurations as default for demo purposes. The sample width and height, as you can see, are 1024 width and height. In previous steps, I've cropped and resized my images to this dimension. And the name of the model is Black Forest Labs Flux 1 Dev. Make sure it's the correct model name. Check one more time, and this configuration file is ready to run for LoRA training. The next step we're going to do is create an access token in Hugging Face for downloading the Black Forest Labs Flux 1 Dev models, and we're going to store that in the environment files. After that, we can run the Python code. So in Hugging Face, we go to our account settings, and on the left side menu, click on Access Tokens. We create a new token here, give it a name, and grant all the access permissions. We copy the token into our folder, and after that, we come back to the command prompt window. We activate the Conda AI Toolkit environment again. Then in the AI Toolkit virtual environment, we can start typing python run.pyconfig, followed by whatever your configuration file name is. Here, of course, you have to use your file names, but then I found out from the GitHub page that this command prompt is kind of wrong. For their extension name, remember to put YAML, not YML. Then press enter again and you're ready to start your LoRA training. It will take a little while, and in the meantime, I just screen captured the progress. I don't want to use up memory to do the recording, so I just screen capped some images of the screenshots here, showing some progress of the generations. As you can see, for each 250 steps of the training, it will generate some images for sampling. That continues until the 2000 steps are finished, and then we come back to the desktop here. As you can see, the command prompt finished in 2000 steps, and for each 250 steps, it will store a checkpoint of LoRA files into the output folder. It took 1 hour 27 minutes with my GeForce RTX 4090 graphic card to process this data training. At the end, it will save in the output folder your LoRA's name as the subfolder name. You can click inside the output folder and click into your LoRA subfolder name. Everything generated for the LoRA models will be in here, saved with SafeTensor's extension file names for each of the training steps. The final one will be the name that you defined in the configuration file, and for each 250 steps after 1000 steps, it will generate one of the sampling LoRA models for the progress of the training. You can also run these few LoRA models as well to test which one performs the best for your image styles. As you can see, after 1000 steps, I have each LoRA model generated for every 250 steps that the trainer ran. We can bring all these LoRA model files into our ComfyUI models folder and go to the LoRA subfolder. I've created a Flux folder to store all of these LoRA files. You can copy and paste or cut and paste into the ComfyUI folder here, and we can start running our ComfyUI and test these LoRA models. So come to ComfyUI as you can play around with the text-to-image. Here I've got a text-to-image workflow running with Flux 1 Dev FP8, and there's a dual clip loader. I like using this way to generate the Flux image. After the models load in the clip loader, I connect the load LoRA nodes. Then in this node, I'm going to select the trained LoRA that I just generated. As you can see, there's each sampling step generated LoRA as well that I can test out. So there's a good way of using a subfolder in the LoRA folder that when I type Flux, all the Flux LoRA models are going to appear in the drop-down menu here. So whichever one you select, you can try the generated LoRA in ComfyUI. With a very simple prompt, I just type my trigger word. Then let's see what I have in the output. I have two sampling custom node groups. The first one is going to generate from the empty latent image, and then the second one is going to be the image to image that's based on this first latent image. We'll see if there's any difference between the two samplings. Our first image looks okay. The character's face is similar to my reference images for the LoRA, looking similar to my AI video character. By the way, in the second sampler, I haven't put any text prompt. I just want to test the LoRA models, and it looks like the first sampling generation is doing better. The skin has not appeared over crooked and balance of freckles dot. But that is the special characteristic of the character's face that I defined in my reference images. Therefore, the generated image will have the dots on the nose skin and the cheekbone. But the second sampling is doing too much, so I don't think I'll need the second sampling for the Flux image. The style of the character is similar to what I have in my reference image for the AI video character. The skin that I defined previously, the ChatGPT text prompt for the AI video stories, and what I generated back then in SDXL, all those images I brought to Flux LoRA training, so it works. And I can also test the other steps of LoRA trained models as well. So here's the 1000 steps LoRA. In the output folder in the AI Toolkit, there are different stages of images generated, as I mentioned, the 2000 steps and each 250 steps. After 1000 steps, there's a batch of images generated just for sampling and examples. And here we have 10 images generated for each 250 steps of progress. So there you have it. We see that there's some difference between each 250 steps for these example images, although they are using the same text prompts to generate, but the colorations, the details of each image will look slightly different, especially the woman's character. As you can see, the first 1000 samplings and the 250, and after that 500. And there's a lot of difference between this character. And then at the end, 2000 steps, these characters are going to be like this one. So yeah, this is the example images showing you the progress of how your LoRA trained. Usually at the end of the training steps, the images are going to be more complete, but that's not always the case. Sometimes in between the training steps, maybe in the 1500 steps, that model's LoRA models can perform well too. So I usually keep all these training steps LoRA models to test before I decide which one to use at the final. So there you have it. This is how you do the Flux 1 depth diffusion model LoRA training. Very simple, basic. If you have experience in training LoRA in SDXL or SD 1.5, you shouldn't have any problems with that. But the main problem of training Flux LoRA models is that you have to use at least a 24GB VRAM display card to train LoRAs. And here, another example, I'm using the text prompt, a woman for the trigger word, and it shows the styles that I have for my AI video character. Riding a bike, and, she's kind of a sporty person, so I have this style of image that can be used, the LoRA, later on for my AI videos to generate further scenes for my AI characters, but sometimes it's not going to be always correct for the new AI image generated in Flux. So we have to test which training steps LoRA models perform the best. And it's not always the final training steps LoRAs that are going to be doing the best for all the images. So it's a pretty easy way to create LoRA using the AI toolkit. And after that, you have different training steps of LoRA models you can test. So here, I'm going to keep testing with different prompts, generating similar styles for that character. Then I can bring it to create AI video scenes for the specific characters. That is it for this video on LoRA training for Flux One dev model using AI Toolkit. So I will see you guys in the next video. Have a nice day. See ya.